Okay guys, today is your first day that we are going to start doing a lesson where you're going to have to watch it home and then do your homework tomorrow in class. So you should have gotten your book, or at least the pages out of your book yesterday, and you should have a page that looks like this. This is page number 3, and this is the first chapter in your book. Okay, so we're going to start there. If you turn that page, it has some activities in here. All of your vocabulary that we showed you yesterday is going to be right up here at the top in case you should forget or didn't write them down. It is listed in your book. This next page, we're not going to use this right now. We may come back to it, but I want to start on page 7. It should say Lesson 1, Rational Numbers. Okay? In this section, you're going to learn why is it helpful to write numbers in a different way. Why is it important that I can go between decimal and fraction and percent? That is what we're going to be working on. And your vocabulary for this particular section are listed under the vocabulary on the right hand of your page. So, first of all, we're going to define what a rational number is. And if I think of a rational number, it says a number that can be expressed as a fraction. Which means if I have a number, and I'm just going to throw some numbers up here, I'm going to write them in pencil because I'm going to erase them. Let's say I have this number. Can that be written as a fraction? Well, the answer is yes. If I have a separate, like say I have this number, yes, that can be written as a fraction also. If it ends, it has an end, then it is a rational number. It does not repeat itself and it ends. So let's do one that repeats. This would also be a rational number because it has a pattern. It has 6s as the repeating number. So this is a rational number. An example of a number that is not rational is a number that does not repeat and it does not have a set end. So a number like this. And if it went on forever in this pattern, well, I can see none of those numbers repeat themselves, and I don't know where it ends because it continues on infinitely, meaning it does not have an end that I can see. So this would not be a rational number. Out of that list, this is the one that is not rational. Okay? So based on that information, we're going to write a definition for what a rational number is. A rational number is a number, and I'm going to abbreviate some things, like I'm not going to write out number. It's a number that can be written as a ratio or fraction and we've already given some examples. It has to have an end, has a definite end, or it repeats. So in that box where it says define in your own words what a rational number is, you need to have something along those lines. It's a number that can be written as a fraction. It has a definite end like 0.75. The 5 is the last number. That's the end of that decimal. Or it repeats like 0.666666 and so on. Okay? So now we're going to talk about some specific examples of different rational numbers. This first one says a percent. If I had a percent, let's say I have 29%, and I want to write that as a fraction. If I have a whole of something, I have 100%. So that's going to be my denominator because it's out of 100%, and I have 29 pieces out of 100. So the fraction equivalent to 29% would be 29 over 100. And if you can reduce that fraction, please go ahead and do that. Okay, so far? Because I can edit this out already too. Okay. Decimal. If I want to take a decimal to a fraction, let's say I have 0.4. If I said that, I know that the 4 is in the tenths place, so that would be the same as 4 tenths because it's 4 parts out of the 10. And I can reduce that to 2/5. So here's my answer here, and here's what my decimal equivalent would be here. As a fraction, If I have the fraction 1/2, if you take 1 divided by 2 on your calculator, or if you do the long division, you'll find out that 1 divided by 2 is 0.5. So the decimal equivalent would be 0.50, 0.5. Either way is correct. It's half. It's 1/2. And half of 100, or half of a whole, is 50. And finally, mixed numbers. Let's say that I have 3 and 1/11. Well, hopefully you remember to do mixed numbers. And I'm going to go ahead and erase this real quick so I can show you real quick how to do a mixed number, but I hope you remember. If I have 3 and 1/11, you may have learned this as the butterfly technique, but this is where you take the big number times the denominator. So I have 3 times 11, which is 33. And then I add the top number to this number. So whatever this top number is, I'm going to add to 33. So in this case, it's 34 over my original bottom number, which is 11. So 3 and 1/11 would be 34 elevenths. So I can turn that into a fraction as 34 elevenths. And again, if I can, go ahead and reduce that. On this one, you can't. Okay? So now you should have a pretty good idea of what a rational number is. It has an end and it does not repeat. I'm sorry, it does repeat. It has an end and it repeats. Rational, if I look at the word rational, it has this word. It starts off with the word ratio. There's a reason why it starts off with the word ratio. Because ratio means, ratios can be written as fractions. So rationals, again, can be written in fraction form. And we call those fraction forms ratios. So rationals can be written as ratios, and ratios are fractions. Okay? All right. Let's go down and look at the real world link. It says during a regular season, I'm not going to read this to you all, but we want to know some ratios of the number of bats. So this is how many he was at bat this many times. That's the total amount of times that player was at bat. So it's out of that many times, 399. And he hit it 126 times out of the 329 times. So my ratio, how many times he hit it is going to go on top. How many total times he was at bat, so this is the times he hit it. And this is the total at bat. And so this ratio would be 126 out of 399. If you can reduce that, go ahead. It does reduce. And once you keep reducing, you get eventually down to 6/19. And that is your final answer. Okay? Remember, if you guys have questions, you have space over here that you didn't need to do this work in, or you have space somewhere along this page, go ahead and write down your answers for class tomorrow. All right. Page 8, rational numbers. And here you have a nice work zone so that any questions that you have, write it down in there, or any work that we do on here, go ahead and write it down. Rational numbers. Well, we already know what a rational number is. It's a number that ends, or it's a number that repeats. It can be written as a ratio, which means it can be written as a fraction. So here's just a nice chart for us to use about what rational numbers are. The first part are natural numbers. Natural numbers are like how we count. When I count students in my classroom, I don't say I have 0, 1, 2, 3, 4, 5 students. We don't include the 0 when we're counting. So natural numbers are all the counting numbers minus 0. We don't use 0, and they're all positive. Whole numbers include the 0. That's the only difference between natural and whole numbers, is whole numbers includes the 0, natural does not. Then we get into integers. Integers includes the negatives and the positives and the 0. And finally, rational numbers is where we get into fractions, percents, decimals, things of that nature. Okay? So let's look at this part. The decimal form of, repeating decimal is what I want to talk about. A repeating decimal is one like 0.666666666 that I wrote on the other page. If I have a repeating decimal, I only have to write, let's say it's 0.66666 and it goes on forever. To write that as a repeating decimal, I can simply write 0.6 with a repetend above the 6. It calls it bar notation, but since we're big boys and girls, we're going to go ahead and use the word repetend because that is what it's called whenever you have a repeating number. Okay? This is a rational number because it repeats. A terminating decimal then, this one right here, a terminating decimal means that it has a definite end. So 0.73. The end is at the 3. It doesn't go on past that. It has a definite end. It's a terminating decimal. If we look over at this side, 0.5 has a definite end. The 5 is the end. So yes, 1/2 is a rational number. 2/5 is 0.4. It has a definite end. So yes, 2/5 is a rational number. But if we look at this one, you could argue, but Mrs. Neely, the 3 repeats. It would have to be the entire decimal that repeats. So the 8 would also have to repeat to be rational. So therefore, this one is not a rational number because it does not repeat. It does not repeat the entire thing. It just repeats the 3s. So let's do an example. These are the examples in your book. I'm going to go ahead and do different examples so that we can start to learn how to do this. Let's do 4/9. If I look at 4/9, you take 4 divided by 9 on your calculator, or if you do the long division of it, you're going to end up with something that looks like this. And it's going to go off the screen of your calculator. Well, if I look at that, well, here's my 10th place is a 4, in my 100th place is a 4, in my 1000th place is a 4. I see a pattern here. The 4 is repeating. So therefore, I could write this as 0.4 with a repetend over the 4. And I know that means that 4 is repeating indefinitely. So yes, that is a rational number. Okay? Let's do some examples down here. 3/4. Well, hopefully this is one of those fractions to percents or fractions to decimals that you have ingrained in your memory. 3/4 is 0.75. 0.75 has a definite end, so yes, that is a rational number. Here's a negative. We haven't talked about any negatives yet, but are negatives included in my rational numbers? Well, yeah, they are right here in integers. There's a -8, there's a -3. There are negatives in my rational numbers also, so the negative really doesn't play into whether or not it's rational or not. So if we look at -2/9, again, on your calculator long division, you'll end up with a negative 0.22222 and so on. Does it repeat? Yes, I can rewrite that as a negative 0.2 with a fraction bar over the 2. A repetend, not a fraction bar. 4 13/25. Well, if I take 4 times 25, I get a 100. 100 plus 13 is 113 over 25. Can I write that as a fraction? Yes, I just did. So that is a rational number. And finally, let's do this one. I think we did this one on the first page. It's going to be a 34 over 11. So is that a rational number? Yes, it is. All right, let's look at page 9. And again, if you need to stop this and spend more time on these, you're more than welcome to do so. That's what's great about these videos, is that you can back them up, you can rewatch certain sections, you can pause them and go do whatever you need to do and then come back to them. So feel free to do that. This is about St. Louis Cardinals and about Albert Pujols. He was at bat for this many times. And if you remember, we did the total at bat on the bottom of the fraction on the last page. Out of that, he had 175 hits. So if I did that on my calculator, if I took 175, it says round to the nearest thousandths. So because it says that, that means that they want it in decimal form. So I would take 175 divided by 530, and this is what you would end up with. Does that repeat? No. It does not repeat as far as I can tell in the calculator. So if I rounded that to the nearest thousandths place, that would be this one right here. And it would be 0.330 would be his batting average. Go ahead and do the next one for a bell ringer for tomorrow. So this is the one that you will need to have worked out and show your work for as a bell ringer for tomorrow. Okay? I'm going to hand this over to Mr. Neugebauer, and he's going to walk you through the rest of the examples and get you started.
Hello, class. Alrighty, let's take a look here at example 5. For example 5 here, it says write 0.5 or 0.5 repeating as a fraction in simplest form. Now, we have an immediate problem here. Our problem is that we want to create a fraction, but we're given a number that's a decimal. And we can't have decimals in fractions. It just doesn't work well. Some people kind of write it that way sometimes when they're doing math with their calculators, but it's not actually a proper way to do it. So what we want to do is we want to take this decimal and basically move it back to where we can kind of, in a way, get a whole number right there. So what we want to do is, it says assign a variable to the value 0.5 repeating. Let n equal that 0.5 repeating. Then perform operations on n to determine its fractional value. So we start here where n equals 0.555. And then if we look down here, we have the n, which remember is this here, times 10. That is going to allow us to actually get rid of part of our decimal here. So let's use an example. I'm going to not use this one here, but I'm going to create a new number. I'm going to use, if you look over here, I'm going to use 0.3. So here I have 0.33, and now if it ended there, if I stopped, it would not be repeating, but if I put my repetant over the top, now I have a repeating decimal. So I have 0.333. I know this repeating forever. If you'd prefer to write it simply like this, that would probably be a better way to do it. Either way is technically correct. So I'm going to take that number there, and I'm going to take n equals my 0.333 repeating. Now I'm putting the extra in there just so we can kind of see what's going on. Now what I want to do is I want to be able to move this decimal back one. Just like here, we only had one decimal spot to move back. We want to move this back one. Well, to move any decimal back one, you simply have to multiply by 10. So on my next line down, I'm going to take n, which is, of course, this number here, and I'm going to actually multiply that by 10. And what that actually means is that I have a 10 times this number n, which was that 0.33 repeating. Now my goal here, remember, let's not lose track of what we're doing. We're trying to get this number to become a fraction, but not have a decimal. So here's how we do this. We have basically 10 times n, which is 10n. So I have 10 n's, okay? Just like if it was 10a, we might call a apples, we'd have 10 apples. Now what I can do to kind of get rid of this repeating decimal is I can take one of these away. So here I have 10n, so I'm actually going to take away an n. Now just like if it was a's for apples, if I have 10 apples, I take away an apple, I only have 9 apples left. In the same case here, we have 10 n's, we take away an n, we now have 9 n's. Equals what over here? Well, if we take 9n, well, I no longer will have this 10. And actually what's happened here, mathematically is I take the n away from this side as well, which remember is the 0.33 repeating part. Okay? So what I'm then left with is just my original 3. Because the subtraction of this 1n takes away the repeating part. When I multiply by 10, remember that moves it over 1 by multiplying by 10. So I kind of basically add 3.33. I take away an n, all those repeating 3 3's right here all go away. So now I have 9n equals 3. Well, if I want to get n by itself, if you remember to last year when you did one-step equations, this means 9 times n. Well, how do you undo multiplying or get rid of multiplying? You divide. So I divide by 9, and what you do to one side, you must do to the other. So I divide by 9. So I have n equals 3 over 9. And I now have my fraction. Now, I'm not done. 3/9 has a number in common, which is 3. 3 goes into 3 and 3 goes into 9. So I always want to make sure my fractions are reduced or in simplest form. So right here, 3 goes into 3 once, 3 goes into 9 3 times. I have 1/3. Circle that. That would be your final correct answer. If you need to watch that again, feel free to do so. But if you're ready to go, just plug along. If not, I highly recommend rewinding, maybe watching that one more time, and I think you'll have it. Okay, if you want to turn the page and look here at example 6. Now here it says write 2.18 repeating as a mixed number in simplest form. Just like the last one, assign a variable to the value 2.18. Let n equal 2.181818 repeating. Then perform operations on n to determine its fractional value. So we're essentially doing the same thing except one little change. Here, our repeating part doesn't just cover one decimal value. It actually covers 2 decimal values because it's not just a 1 repeating. It's not 2.11111. It's not 2.88888. It's 1818181818 as you see here. So we can't just move the decimal like we did on the previous page. We can't just move it back. Let's see here. We can't just move it back 1 space to get rid of the repeating part like we would here. We actually have to move it back 2 spaces. So I'm going to write, let's try 3.15. There's some workspace over here I'm going to utilize. So 3.15 repeating. Now I need to move this back 2 spots to get to the back of the repeating part, to get basically to the end of the repetant. So 1 spot was times 10. 2 spots is times 10 again. So 10 times 10 is 100. If, for example, I had 3.158 all repeating, that's 3 spots behind the decimal all the way to the thousandth, and that would be a times 10 times 10 times 10, which would actually be 1,000. Luckily, we don't have to do that here. We just have 2 spots, so I'm going to be multiplying by 10 times 10, which is 100. So I'm going to start and show my work. I need to show what my n variable equals. That's 3.15 repeating. Okay. Now I want to multiply that by 100. So I'm going to take 100 n's, and that will then equal 100 of the 3.15's. Okay. Now, how many n's do I want to take away? Oh, let me put my repetant on there. How many of those do I want to take away? And of course it's 1515 forever here, but we can just stop it there. I'm going to do the same thing. I will take away an n. Okay? Which leaves me then with 99 n's on my left side. Now, when we take away, essentially what we did here is this subtracting n. Think, what does n actually equal? It equals this part right here, okay? And we moved it over. So remember, taking away that n basically gets rid of all of our repeating decimal section right there, okay? So when I move this decimal over 2 spots up here, I actually have what number? 315, correct? So my 99n will equal 315. All right? Now, what do I need to do next? Well, our goal isn't just to get a whole number. We want a fraction. We want n by itself. So my final step is simply to divide. Now we have an improper fraction there. If you can simplify it, that's great. I don't think that one does.
We'll accept that answer. It's good.
We'll accept that answer.
Okay, guys, if you have any questions, just let us know. Make sure you write your questions down and bring them to class tomorrow. And we will see you then. Have a great night. Bye. Hey guys, okay, so there was a problem with that last example, and Mr. Neugebauer and I didn't see it until just now, but maybe you can find the problem. Go back and look at your examples, see what the mistake was, and I bet you're probably going to see that on a quiz coming up. See ya.